Let's go into limits, peeps. It's gonna be awesome. So limits are like the engine behind all things in calculus. So as your teacher teaches it in class, or maybe I'm your teacher for that class, you're going to be learning some processes that have to do with limits. So we're gonna start out here with an understanding of graphical and numerical calculation of limits. What does that mean? Let's check it out. It's not so bad. So a very simple definition of a limit. That's what we want to look at here. So the very basic definition of a limit is if you've got some point on a graph, any point, and you're approaching that point from both sides in the x direction, the question is, what y value do you approach? Another way of saying that is, as you approach the same x value of some function from both sides, what is the y value that you get out? So that notation that you see right here, that is limit notation. It says the limit, that's this part, as x approaches some x value, we'll call it c, that's from both sides, remember, of the function f of x. So let's look at that visually and what all this means. Essentially, let's say that you have some graph right here. So you've got the graph with a point c, f of c, right? You plugged in a value c, you got out some y value f of c. Let's say that we approach this value, this point on this graph, from the left side as well as from the right side. So imagine you're a bug and you're traveling along the curve here, and you arrive at the point from the left as well as from the right. What would the limit be? What y value do we meet at? F of c. So in that case, that's our y value. And we'll do it with some numbers shortly. Don't worry about it. We're not going to do it all formal-like from here on out, I promise. Okay, so let's take a look at something a little simpler. This is some random function. We call it g of x. We're asked to find the limit as x approaches 1 of g of x. What does that mean? That means that if we look at this graph from both sides, or side, of x equals 1, we approach from the left side, and we approach from the right side. What is the y value that we approach? Well, that y value is 1. So the limit of g of x as x approaches 1, or the limit as x approaches 1 of g of x, is equal to 1. And you might be like, yeah, but Mr. Groden, or Matt, or whatever the heck you want to call me, this thing right here, that's a point. Why isn't that the limit? Well, did we approach that value from both sides? No, we absolutely didn't approach it from both sides. We approached a y value of 1, even though there's a hole there. We approached from the left and from the right, and though we didn't arrive at a y value of 1, like we weren't able to stamp a point there, we approached the y value from both sides. And that's the important part of a limit. We'll do more on that as this lesson goes on. Got it? Sweet. Let's do a little bit more with some numbers now, shall we? So we'll look at this now with, well, actually, when I said numbers, it's more so like graphs of where they don't exist. And so we'll look at numbers in a little bit. But here what we're talking about is we're talking about limits and where they don't exist. And like I said, there's some numbers here. It's a little less general than the last time. And it's important to know where a limit does not exist. So here's option 1. We're approaching an x value of -1 of f of x. And as we approach from the left side and then from the right side, we notice that from the left side, we approach a y value of 4. You know, you're walking from the left up this slope, and we approach a y value of 4. But from the right side, we approach a y value of 2. What does that mean? It means that the limit does not exist. Some teachers will write that as DNE. Right? That's not formal, but let's just write DNE. For the limit does not exist. Again, that's because we approach a different y value from each side of the x value we're interested in. So that's where the limit is not the same from both sides. Here, we've got two reasons why the limit doesn't exist at 0. We've got the limit as x approaches 0 of 1 over x. Well, at x equals 0, we do not have the same y value we approach. As we approach from the left side, look at that graph, it's going way down. And as we approach from the right side, whoop, that thing is going way up. So, for one reason, we can say the limit DNE, or does not exist, is because the limit from the left does not equal the limit from the right. for the same reason here. We don't approach the same y value. Or you could also say that we have unbounded, right? Unbounded limits. We are going down to negative infinity as we come from the left, and as we approach from the right side, we're going up to positive infinity. Anytime a limit approaches an x value and the y value goes upwards or downwards to one of the infinities, negative or positive, the limit does not exist. So that's an unbounded limit or an infinite limit. It goes on and on forever. So the limit does not approach the same y value from both sides, so it doesn't exist. Same reasoning here, and it also goes to infinity. And then you got one of the most rare occurrences here, which is the limit does not exist yet again as x goes to 0. So we're saying what happens as we get really, really close to 0? Well, you can't see it here, but we have what is called oscillation. What does that mean? That means that as x approaches 0, because that's what we're interested in right here, the limit as x goes to 0 from both sides, the graph of cosine, that's this, of 1 over x, is going like this. It never makes up its mind. It never says, oh yeah, it approaches a set y value. As we get closer to 0, we don't know what the y value is that we approach. So the limit does not exist. Why does that happen? Well, as x goes to 0, we get cosine of infinity. Think about a cosine graph. It's going on and on forever. So as we approach 0, we're taking the cosine of a number that's constantly changing. It's like you're going around the unit circle and never stopping. The graph never makes up its mind. So the three forms of limits not existing are the limit not existing because the y value is not the same from both sides, or we go to infinity, or oscillation. The graph doesn't make up its gosh darn mind. There you have it, where the limits don't exist. All right, now a couple of real easy ones where the limits do exist before we close out this part of lesson 1.2 and the intro to limits. And then we'll go on to some other crazy stuff in the next part of the lesson. So the limit as x approaches 2 of x squared. What we're going to do is we're going to find each limit using its corresponding graph. So we go to x equals 2. Where is that? Well, x equals 2 is right here. And so that would be right here, this point. Well, as we approach from the left side and the right side, we approach the same y value, so the limit exists. And that's at a y value of 4. So the limit is equal to 4. Not that bad. So the limit exists, it's equal to 4. How about finding the limit as x approaches negative 3 of that same graph? So where's x equals negative 3? Well, that's right here. Boom. As we approach from the left side of that value and the right side of the value, we approach the same exact y value. That y value is a value of 9. It's as simple as that, peeps. Just see what y value we approach as we approach that point from both sides of the x value. Now we'll take a look at the graph of some random one, y equals x squared over x cubed minus 1. Who makes up these functions? Honestly, I did. It's a pretty rad function though. Come on, look at that awesome looking bump. Anyway, let's keep rocking and rolling. So as we have, I just think a graph looks awesome like that. I can't help it. Anyway, so the limit as x approaches 1 of this function. Well, x equals 1 is right here, and ooh, we've got a vertical asymptote right there, right? If you take a look at it, that thing is going to infinity. Because we're going to negative infinity from the left, positive infinity from the right, we have that the limit does not exist. DNE or does not exist, or whatever your teacher wants you to write to give a proper answer. Does not exist is formally correct. Now let's look at 0. The limit as x goes to 0 of this same function. Well, here's 0. Can we approach the same point from both sides? Whether it's a hole or not, absolutely we can. And it's a solid point, which doesn't matter with the limit. Because we approach the same y value from both sides of 0, and that y value is 0 itself, our limit is 0. That's it, peeps. In the next video, we're going to do a whole bunch of limits with graphs. It'll be really sweet. Thought this was a nice way to cap off the first of a few videos with graphical limits.